I will start with RT13 in this video. It's a sound wave velocity and frequency. Okay. A student states the distance between a compression and the next compression, so that's basically a wavelength, for a sound wave with a velocity of 800 feet per second and a frequency of 400 hertz is 2 feet. Okay. If the wave had a higher frequency, it would travel faster. This statement is wrong because what's going to happen is the speed is going to stay the same because the medium hasn't changed. So if you travel in, if the frequency is higher, the speed will remain the same, but the wavelength will be less because there is, for a constant speed, there is an inverse relationship between frequency and wavelength. RT14, it says to rank the waves based on their speed. Well, these waves, regardless of their shape or amplitude or whatever, frequency or whatever, they're all traveling in the same medium. So they have to have the same speed. So the answer is all the same. It's right here. Okay. So a dropped speaker. I guess we drop speakers in water. A waterproof siren is emitting sound at a single frequency. The siren is dropped from air into water. If the frequency of the waves produced by the siren, okay. Now, the frequency, it's what's being generated. So the frequency here is generated by the siren. So I'll give you an example. So like if you hear a fire truck while you stand in here, if you are underwater, you should hear the same, you should recognize that it's a fire truck if you are underwater. If the truck is outside and you're underwater, it should be the same sound. So the frequency is basically what's being generated by some source, in this case the fire truck, but in this problem here is the siren. So the frequency is not going to change. Okay? What's going to change is the speed. So in this case here, the speed is going to change. So you go from air to water, the speed will be higher in water. Let me write it out. Frequency stays constant because it depends on what's on the siren. It's the same siren whether it's in water or in air. Speed has to increase because you're going into water from air, which means the wavelength will also increase. Okay. Number 37. Sound waves traveling through air have a frequency of 200 cycles per second. CPS stands for cycles per second, or hertz. So speed is lambda times frequency. Your lambda is 1.3, your frequency is 250, and you can do the math. And you should get 325 meters per second. The temperature in air is 15 degrees Celsius. This is in air. So right away, you can use this formula. You know that you're probably going to have to use it. Okay? You get your speed to be equal to 340.5. So if you ever need the speed in air, okay, I would just use room temperature. So go for about 20 degrees. So the speed of sound in air is about 343, 345, something around there. Okay, somewhere between 340 and 345, you're safe. A tuning fork vibrates at a frequency of 320 hertz. What's the wavelength of the sound? So V equals lambda times frequency. We just found the V. We want to find the lambda, and we have the frequency as 320. So the wavelength should be 1.06. These are pretty straightforward. It's very linear. So there's not much math to do here. It's all basic algebra, not even algebra. All right. The speed of sound on a warm afternoon is 350. So based on that, you can probably find the temperature if you have to. Okay. A sound from a whistle has a wavelength of 1.2. What's the frequency? Again, V equals lambda times frequency. 350 for V, 1.2 for lambda. You can find the frequency by dividing, so you should get 292 or close to 292. The speed of sound in air is 336. So which means that's probably cool, right? Because around 340, 345 is room temperature. The frequency is 250 hertz. What's the period this time? Well, the period is 1 over frequency. So it's just 1 over 250 in seconds, and it is what it is. So it's 0.004. What is the wavelength? So V equals lambda times frequency. You have the speed, you have the frequency, you can find the lambda by doing 336 divided by 250, and you should get 1.34 meters. Okay, number 41. The crack of a bat hitting a baseball is heard 0.36 seconds after the hit. The temperature is 26 degrees Celsius. What is the speed of sound? So I think we're going to use the temperature formula. 331.5 plus 0.6 extra degrees Celsius for 0.6 for every extra degree Celsius. And that should give you 347.10. How far away? So I think we're going to just do V equals D over T. Now the V already found. The time is 0.36, and you should find your okay, and you should find your distance. A stone is dropped into a stream from a bridge when the temperature is 15 degrees. Okay, the splash is heard 0.6 seconds after hitting the water. If it says 0.6 from the moment you drop it, it's a little bit more involved, and you have one in the textbook like that, which means now you have to take into consideration the time that it fell to get to the bottom. So you have to kind of like do a free fall, combination of free fall and the waves here. So if you go to the textbook, you're going to find one that I put there. Okay, so here it's after you hit the water, so I guess we just do V equals D over T. Okay, you want to find D, you have the T, you can find the V from the formula that has temperature. So that's that. Okay. Oops. Okay. Now, the next two problems talk about echo, right? Which means it's the reflection of sound. It hits somewhere and it comes back. A hiker shouts across a canyon and hears her echo 3.8 seconds later, which means it took half of 3.8 to get there and half to come back. The temperature is 12 degrees. How wide is the canyon? Again, V equals D over T. I think the V we can find from the temperature formula, and that should be 338.7. Okay, D over, you do 1.9, not 3.8. Now, if you do 3.8, that's there and back, which means, and you take that distance and you cut it in half. Okay, the last one, 44. The echo of a ship's fog horn reflected from an iceberg is heard 5 seconds after the horn is sounded. Again, another echo problem. It takes 2.5 there and 2.5 back. The temperature is -10. How many meters away is the iceberg? Okay, so I think we can find the speed by doing 331.5 plus 0.6 times -10. So this is going to be, what is that, 3, subtract 6 from here. What is that, 325.5. Yeah, that's the speed. And then we just do speed is distance over time. Speed is here. The time is 2.5 seconds. And you can find your distance. And that's it.